Hey everybody, Jason here. I hope you're all doing really good. Today I'm working on an iPhone 7 that was originally sent here for no image, but it actually wound up being a liquid damaged prior repair attempt. Oh Lord. This is going to be the second part to that video, so if you haven't watched the first one yet, I encourage you to watch it first. I will link it up here somewhere. So now that I have a green light to repair for data access only, I am ready to proceed. Okay, it's not like a complete green light. It's more like a flashing yellow light, a real slow flashing yellow light. So a couple of people asked why I did not dig right in and just start repairing this board. This is a board that has been liquid damaged from top to bottom. There is stuff hiding like all over the place, little corrosion castles and things like that. It has had liquid all around the baseband power management IC, liquid all around the boost IC. Oh look, we've got probe marks all around the boost IC. No image, no backlight, right? So aside from the widespread liquid damage, somebody has also taken it upon themselves to try to repair this thing. So, we were missing this chip down here. And if you're in this business and you've been working on the iPhone 7 and 7 Plus models, there is enough stuff that goes wrong with them phones without all this other carnage. And whenever you can get online and you can buy this phone, you can buy a replacement iPhone 7 for less than $100, it doesn't make any sense for me to sit here and try to rebuild this board from end to end for a product that's going to be less stable than if you were to just spend $95 and bought a replacement iPhone 7. So I'm going to get this to the point where the data can be transferred off of the phone, and then that data can be transferred over to another working iPhone. So back under the microscope, first I'm going to make sure we still have all of this ball squeezage here. We do. So to get the data off of this phone, we are going to need working image, we are going to need working touch, and it is going to need working USB. So first off, I would like to make sure that it powers up before I start doing anything else. Now, I don't see any evident humongous corrosion castles or anything anywhere that would prevent me from wanting to power this up, except for maybe that. Let's see if I can smudge that out of there with some alcohol. Seems to be just a little bit crusty. Well, there may just very well be no other good way here other than ultrasonic cleaning. Let's see if I can finagle this down into that crack. Oh yeah, there we go. Looks pretty much brand new. I think I'm going to go ahead and extract this little capacitor here on the right. It has easily came loose just from some minor wiping. I am starting to get really concerned about all of the probe marks all over this thing. Now, although I am going to be ultrasonic cleaning this as part of this process, I need to see where I'm at here. I need to know if this thing is powering on. I need to know exactly what we've got. So to test this board, I'm going to hook it up to my DC power supply. This enables me to see what the current going into this board is and gives me an idea of exactly what is going on. So I have my supply set to 4.1 volts and I'm allowing 3 amps of current to flow if it would like. And I have turned the power supply on. We're drawing 0 amps of current. That's a good sign. Next, I'm going to power this board on by shorting the power on button pin. On this model, it's going to be this pin right here. Basically, to get a power on signal, we just need to pull that pin to ground. So we are getting nothing. That's lovely. So to get this thing to power on, basically we need to take pin 13 on this connector and pull it to ground. So under the microscope, that looks something like this. I'm just going to grab ground off of this end of the connector. We are getting 700 milliamps, 120, 140. Looking like a good sign. It's looking like it is actually booting. I'm going to let this continue its startup here. I can live with sending this back, able to start up with the data intact. There are a lot of data recovery places that just will not do anything without the passcode because it is actually risky. So for this customer, I'm going to be trying to send this phone back able to start up to where he can unlock the screen and it will connect to a computer. But everything else as far as cellular service, audio, and I've seen corroded pads all over this thing. There's just no way that I can guarantee this to be a working phone. So it looks like the board is fully booted. It's sleeping now at 50 milliamps or, ish. And now I can proceed with trying to get image and touch working. Isn't this lovely? So the first thing I'm going to do is have a look at this connector. We can see we've got some carnage going on here next to the connector. There is something missing here. I mean, like right here. I'm not going to worry about that just yet. Let's just see what we can do to clean this up here. I'm going to take my number 11 X-Acto blade and just kind of scratch around on these pads. Now, in the first video, I had indicated that most all of the other pins are okay, and they pretty much are. Now, if I was just going to do the data recovery on this, like right here and now, I wouldn't be worried about this stuff over here even the slightest bit, because I'm sure that this will work right now, but I need to make sure this thing will survive a little bit of a car ride and the shipping courier throwing it around. So I'm going to go ahead and shine and tin these up a little bit here as well. Now, the issue with the screen not getting backlight would be absolutely be related to these 3 pins here. So I'm going to be sure and clean this up some. All I'm doing here is just scratching the oxidized layer off of this stuff. Corroded layer, whatever we want to call it. Because I'm going to need some metal to stick. Dun da da da. Da da. Almost there, and then I can finally get out a tool. It feels like I'm 3 or 4 videos deep now without touching my tool. All right, so I've got that all shined up. Now back over to the other end here. First, we're going to get some of this nice, pretty liquid on it. This is flux. It's needed if you want solder to flow. So I'm going to begin cleaning this up with some 6337 leaded solder. And my micro pencil tip is pretty stinking wore out, so it's not really wanting to get down in there too well. There we go. There we go. Isn't that beautiful? Those are okay. It looks pretty much brand new. Well, I mean, brand new for the kind of phones I've got coming around here anyways. Let's go ahead and do these backlight pins. Get some flux on there. I'm dipping my iron in 6337 leaded solder. I'm holding the temperature of the board up with my left hand in the hot air. And I'm touching the board with my soldering iron in the right hand, because this iron may not produce enough heat to do it all by itself. Okay, so that middle one's not wanting to stick. I'm trying not to make too big of a mess out of this because I don't want to have to replace the connector. That wouldn't be any fun. I mean, maybe it would be fun for you guys, but not for me. I need to get this done. All right, let's warm this up pretty good. And then I'm not going to care a whole lot if I get solder on this little metal thing next to it. I'm just going to kind of get down in there and just start like freaking jabbing around. Did I get it? No, I didn't get it. Oh, what a bummer. Ugh. Well, isn't this embarrassing? All right, so I'll just start kind of trimming this up with the blade. And at this point, I'm actually intentionally taking some of the plastic out. I'm like cutting into the connector. And I'm gouging it out to expose some of the top of this pin here. Now I'm going to do the same thing to the next one over. I need to be able to see it a little better, but also it needs a little bit more pin exposed, because what of the pin is exposed is too freaking nasty to let me weld to it. Oh yeah, we're getting warmer now. Almost there. Didn't I say that once before? I don't think so. Oh yeah, baby. This is so beautiful. I mean, it's just pretty much just like it was from the factory. Let's just get some more flux on here. All right, now let's see if I can get it to stick. You know, I don't know about you guys, but I think I've had just about enough of this creepy little bracket. I'm going to go ahead and just get that out of the way. Maybe we'll put that back on later. Maybe I won't. Almost there. Oh, yeah, baby. Come on. Let go of the board. There we go. Yeah, see? Now I can get right in here and solder these pins without having to be all stressed out. Alright, so let's just get us some nice new solder on there. Number 1, 2, 3. Oh, it's so much easier without obstacles. Oh yeah, now I can just blast right through here. You know, it's like trying to replace the clutch on a front-wheel drive or something without removing the engine. Like, just remove the freaking engine. I think I better give this one over here just a little bit more love. There we go. That looks pretty thoroughly loved. These pins over here are still looking just a little bit swanky, so I'm going to show them just a little bit of love too. Oh yeah, there we go. Excellent. Now let's flip it over and have a look at the other side. Now on this side, I know that we are missing our backlight driver. That is what's supposed to be sitting here. So I'm going to get this board prepped up and ready to receive a brand spanking new backlight driver. First, we're going to get rid of these little plateau-ish, probably lead-free solder remnants. I mean, as far as getting this board back up and running for data access, it's really not that bad. But to try to send it back, ready to make phone calls and all the other bells and whistles, maybe in a past life, but not in this present life. No freaking way. I will be eating out of trash cans if I try to do that. Guaranteed. It's going to need some more flux on it, isn't it? Looking a little dry. There are really only two things that we need to get this solder to behave really well, and that is flux and heat. Get enough of both of those and we'll get nice little dome pads on there. Now, I'm going to be leaving both of those diodes. No, I'm not. I'm not going to leave those diodes alone. There's no way I could send this thing home in good conscience with elephantitis. There we go. So we're ready for a new backlight driver, and I am embarrassed to say I don't have any in stock. So I'm going to be using a donor board. It is a plus model, so it has basically two matching backlight circuits. Instead of having one of each type of diode, we have actually two of each types of diodes. Instead of having one backlight driver, we have two backlight drivers. We're only going to need one backlight driver though. I'll take the one on the right. She's perfect. So we're just about up to temp here. Any moment, there we go. We have us a brand spanking new backlight driver. Let's move this over to reballing station B here. Now in order for this chip to hold up to the challenge, it's going to need balls on it. And in order to have balls on it, we're going to need to get rid of the old solder. The solder that's on here, this is lead-free solder. It melts at a way higher temperature than leaded. I like to go ahead and squeegee that off before we put our balls on here. So very important to reballing this is making sure that it's cleaned off without any sticky flux left over, because the paste that we're going to put on here, if it is too wet, it just kind of wants to run everywhere. It's not so important on the smaller ICs, but larger ICs, it'll cause you like major nightmares. There we go. We've got that dried off nice and pretty. Next, we are going to need some solder paste. This is Chipquik SMD 291 AX50T3. It is just some solder paste in a, ooh, I don't want to get my freaking hairy blade all in there. Instead of it coming in a syringe like you normally see me using, I'm actually buying this stuff in a tub now. It's much easier for me to work with like getting it to dry out and stuff, because the stuff really is kind of too wet. So I'm just going to take just a little tiny little dab of this. I mean like a tiny little dab on the tip of my blade. Next, I will get my stencil all lined up. Kind of move it around all directions here and make sure I'm not skipping any balls, right? That's no fun. So with the stencil all lined up, I'll just take this tiny little bit of solder paste on the tip of my blade and just smear it all down in the holes real good. It's sort of like putting peanut butter on a waffle. Only it's not a waffle and it's not peanut butter. All right, we got that smeared in there nice and pretty. Next, I'll start warming this up. And we want to try to warm up the entire stencil as evenly as possible, because if you do it too much in one area, these stencils, they will warp, and the solder paste runs everywhere, and it makes a god-awful mess. So we're almost up to temp here. In any minute, we're going to see bloop, ballage form. And there you have it. We have nice semi-symmetrical balls. So we'll take our brand spanking new IC with semi-symmetrical balls and hair, apparently. And we'll sit it right down here where we won't lose it. So it is excruciatingly important to know exactly which way this IC is supposed to be orientated. As we can see here, A1 will be up to our top right if we're looking at it in this direction. So we've got the same orientation on the board there at the bottom right-hand corner of your screen. And then on the IC, you'll see that we have this dot. That dot is our pin 1 marker. That marks which direction this chip is supposed to be turned. So it's actually going to sit on the board just like that. So we'll go ahead and add just a little bit more flux to it. And see if we can give this thing the gift of backlight, shall we? I'm going to start warming the board up slowly. I've got my hot air set on 340 degrees C, and my airflow is 40. Now, one really good thing about tacky flux is once it starts to do its thing, as soon as you take the heat away, it gets like hard. It's really tacky. So from this point, if I let go of this IC, it's stuck in place already. Now the solder's not melted. I don't know, maybe some of it is, but tacky flux, it's made so you can like tack it down. So now that we gave it a little tacky, I'm going to warm the entire area up here, and we're just going to let it settle down onto its balls. Any moment, fellers. Almost there. Oh, yeah, meltage. Okay. So we've replaced the backlight driver. I have resoldered the broken pins. There was a, back on the front side of the board by the connector, there was a component missing right here. What is that anyways? We have, let's see, we've got a vertical component here. That's a capacitor. That's fine. We have cap. They're all caps, which mean we don't have to do nothing. We can just leave it. So I think it is safe now to go ahead and get this connector cleaned up. We just want to make sure that all of the Chipquik SMD 291 flux is out of it, because that stuff is really sticky. And once it's been heated and then cools, it seems to dry hard as a rock. It is properties that I have learned to love and also hate, but for the most part, I use it as like a special tool. That stuff can really help you finagle components around that are too small to grab. All right, I'm not going to go full-blown spotless on this yet because I do believe I'm going to ultrasonic clean this board. So really, I just need to test and see if it works with working image, touch, and backlight. Now, we have this cap down here that's all wonky. That is a VDD boost cap, and for this very moment, I'm going to be leaving that alone. Well, alone, aside from grabbing a hold of it and properly removing it from the board. So for my next test here, I'm going to be using a known good screen. For this, I've made sure to choose the very best screen that I have. This test will be done using a DC power supply. All right, we've got the power supply on. I'm going to short the pin over here to prompt this to boot. 60 milliamps, 70 milliamps, 140. We have nothing. No image. Oh, I'm a miserable failure. So working on this like a caveman is not working out too well for me. I basically just put some solder on it and some flux, and I looked at what was broken and I made it look pretty, and that actually did not work. So we may have some other pins here broken, but most of all there may be some other components that are messed up. I wonder what is disconnected. I'm going to put my meter in diode mode, and I'm just going to buzz around the connector here and see if I can find any readings that are out of whack. 0.58, 62. Paul has added crowdsourced data to this, so if the data is available, then I can see what the diode mode is supposed to be. So it should be reading 1.5 on that one, which we are getting exactly 1.5 there. Moving right on across here. I'm just looking for any broken lines, and this is a very common thing to do whenever you don't have image or you don't have cameras, or something that is hooked to one of these connectors does not work. Let's check our backlight pins now. So we get a 6-1, we get a 50, and we get a 6-1. That is exactly what we should be reading. Now how about the top row? 4-9, 5-1, open line, that's the third pin over. That's what it's supposed to be. Let's see, how about our enable line and our reset line? Our reset line is going to be 1, 2, 3, 4 pins over, then we're going to skip one, and then, so pin 4 and 6. Here we go, here is LCM reset. A 0.49, that is an acceptable reading. And then here is Chestnut Power Enable. Wait a minute. Number 6, right? 1, 2, 3, 4, 5, 6. I am getting an open line on Chestnut Power Enable. I know that that line should at least read something, but according to Flexboard View, this line is supposed to be reading a 0.51. So if we trace that down on the board view, I like Flexboard View because it draws these nice lines. We can see that that comes right over here, and that is going to FL3913, which is on the back of the board. That is where we had all of this ball squeezage. So let's just see if we get the same faulty diode mode reading here. I'm going to put my red probe on ground, and I'm going to use my black probe to do the probing. On this side, I'm getting a 0.49. And on this side, I'm getting a 0.49. That means that that little filter there is not blown. What does that pin look like? So we're just going to count. 1, 2, 3, 4, 5, 6. Is it loose? No, it is not loose. So we're getting nothing to the enable line there, but I've traced it back to the filter on the back side of the board, and we're getting a proper reading there on both sides. That makes me think that with all of the ball squeezage that we have going on here, this filter may actually be detached. Now we could always just jumper 1.8 volts over to Chestnut Enable and get that signal there for this chip to power up. But again, I would like for this thing to be working, you know, semi-properly. Oh yeah, look at this. Yeah, see here? I'm just barely touching this stuff. I've not came anywhere close to heating this up to the point of melting solder. Yet these components are just literally coming loose like nothing. And it's because they were heated to the point of floating with this rubbery underfill or overfill. It sort of changes shape and it'll pick them right up off the board. So let's get this stuff resoldered back down. Now again, this is not something here that's caused by liquid damage. This is something that was caused by the heat from the prior rework attempt. So we'll just kind of blow that stuff out of the way. Now I moved, how many of these other ones are loose? That's pretty much the only ones. So what else did we move here? Having a look at Flexboard View, we have moved one that is going to get some communication magic over to the touch portion of the display. We're going to need that. And then we also moved this LCM to Chestnut Power Enable. We need that for the display to turn on. So we're actually going to need both of those. Let's get this shined up and ready to receive some brand spanking new components. Again, we're using 6337 leaded solder. There's 1, 2, 3. Oh, it's just beautiful. 4. Now for this, I am going to be using some brand spanking new components, all jokes aside. These are 1005 inductors. There's one laying right there at the tip of my finger. We'll just sit that right on down in here like that. So as the board warms up, the tacky flux gets runny and sort of coats everything. But ultimately, we are waiting for surface tension to do our work here. And that component is just going to settle right down into place. Here we go. Any moment. Sometimes I need a little help. Nope, there it goes. All right, there's our first one. Now, without letting the board cool down too far, we want to go ahead and get our second one in there. Come on, baby. We need it to at least somewhat line up, and then surface tension will take over from there. All right, here we go. Oh, oh, oh. There we go. All right, so we have us a brand spanking new filter installed for the Touch UART and also LCM Chestnut Power Enable. And I'm not kidding, these are actually brand spanking new filters. So now let's see what that pesky little enable signal is reading. And we are getting 1, 2, 3, 4, 5, 6. Ooh, yeah, we are getting a 0.5, baby. At this point in the game, I would be willing to place money that the very next test run produces an image. And backlight. Backlight's kind of a stretch. We should at least get image. So I'm going to hook my test screen back up. We're going to need a little bit of power supply here. I have that power supply set back on 4.1 volts and we have it turned on. And next I'm going to push the button to boot and 1, 2, 3. Boot. We are drawing 70 milliamps, 190, 150. Sure should have an image. Woohoo, we got an image. Let me hold it back here and then maybe I can save myself a bunch of work blurring out a bunch of personal stuff here. So let's see if this thing will start up for me. All right, we have lock screenage, but do we have touch? No, this thing, we have zilch, no touch. Yeah, I'm going to be really honest here. Troubleshooting no touch can be significantly more difficult than troubleshooting no image. With image, it's really just straightforward. It's, just there's a handful of basic lines that need to be there, and it, should get an image. I'm just going to kind of peruse the board here and see if there's anything that just immediately jumps out at me. Well, let's look back at the back side of the board here. This thing had all sorts of crazy carnage going on. We do have components here that are just like noticeably, like visibly bad. The first components on my list that I'm going to be going after are, well, pretty much everything here. I'm going to say this is most likely a capacitor that is missing right here in this spot. But these here are more likely to be inductors, and they just look, they just look bad. So again, I don't have the board view file for this exact model of iPhone 7. So I have loaded up PhoneBoard here to continue this process because I need to know exactly what these are. So the first one I am concerned about is this one right here. This is a line responsible for bringing a signal that has Mason in the name over to the connector, which we know is related to touch. The next component that I'm interested in is the next larger one over here. It is also very much bad looking. That is one that is also responsible for delivering touch. And then we've got this little booger out here that's kind of turned the other way. What is that? 5V7, AVDD, HCon. Okay, so without this one, this is more of an image related line here. So we have basically two components here that look really bad that are related to touch. If we check these two components in ohms mode, since they are just inductors, they're basically just a wire coiled around like a Ferris core. These components should read zero, just pretty much almost 0 ohms across them. So the first one, we are getting 0 ohms-ish. I'll take it. It's pretty low. The second one, what is it reading? Ooh, is that in the mega ohms? Did that just say mega ohms? Push real hard. No, I just wasn't crunching through the coding. So although those look like complete total trash, they are most likely functional. What's that little, I'm going to say resistor in between those? That is LCM Panic B. What in the heck is that? All right, so looking back at the connector here, I am going to be going after things that pertain to touch, and I believe we are most likely going to be looking for missing signals rather than like shorted lines. So we've got image. I'm pretty well certain we've got good EEPROM connections here. I'm not going to be too concerned about this AP to Mamba stuff because I think that is only to do with the other connector. So we've got tons of stuff here that are labeled for touch. And I'm just going to buzz right across here and double check all of it. I'm going to start from the left to the right. So we're going to have a connection followed by 2 open lines, followed by connections all the way until we get to ground. So that makes it pretty easy. So we'll get connection, connection, looking good so far, followed by 2 open lines. And then we should get normal readings all the way up until the ground next to the part that begins the image chokes. I'm not seeing anything broken on that row that pertains to touch. What are we getting on our touch lines down here? How about PP1V8 touch? That's going to be pin 1, 2, 3 for the 5th pin over on the bottom row. That looks good. And then the rest of the pins on the right-hand side of that, those are also for touch, so I'm going to check those as well. 4, 9. So far, these are all looking pretty stinking normal. Now, I just ran into a ground, and I believe we're going to have an open line on the right side of that. Yep, that's normal. Well, I'm not finding any connections broken out to the connector, so that's kind of strange. I guess it could be my beloved test screen. I don't understand what could possibly be wrong with it, though. So for the next part of this troubleshooting, I'm going to be using an old Boy Scout trick. This handy little gizmo is going to allow me to feed the display signal out to the display, but at the same time gives me some test points that I can use for testing. To be on the safe side, I am going to do this testing using a different screen. Both of these screens are screens that I would have considered to be known goods, so either one should be fine. Wait a minute. Pretty sure I'm hooking that up backwards. Yep, hooking it up backwards. So this is actually going to get flip-flopped. Hooks up there and flips over. So it's like, I don't know, phones this way, screens that way. I'm going to get our power supply hooked up. And then we'll push the button to boot in 1, 2, 3. Boot. We are drawing normal current. We should get a logo. Come on, baby. Oh, you dirty rat. We're back to having no image. Okay, so I've probably made a mistake here and I changed too many things at the same time. Just to make absolutely certain. Let's just go ahead and connect the screen that we see and get an image already. Well, isn't that just lovely? Now, is it my iBridge that is bad? Or... Okay, well, let's just do one more random bit of troubleshooting here. Let's throw that garbage aside. And let's just test this entirely with a different screen. Let's plug this screen in here. Now, it is entirely possible that my chip quick flux is just too thick, and that's forming a barrier, a dielectric barrier. There we go. See if it boots. Huh, we got image there. Well, that means this doesn't work at all. It is possible that the connector just having flux on it is preventing touch from working. All right, we're back up and running. Here we go. Drum roll, please. Dang, still no touch. And now we're using a different screen, so, Well, my idea with using iBridge is so that I can check to see which touch signals are present and which ones are not. I have used this many times in difficult situations, but it's just not producing an image today. I'm not going to troubleshoot my troubleshooter. Not today. You know, I'm really hesitant to blame the Chestnut IC. I believe they've had it off of here before, but we have working image and we have working backlight. So I really don't feel like it's going to be an issue with Chestnut. How about this little thing hiding out here? I know we had normal diode mode readings everywhere, so it shouldn't be... Yeah, it shouldn't be that. I have verified that everything is connected to the connector. Anything else sort of like popping loose due to heat? I'm just going to kind of rough my way through here and gouge this up and see if anything moves. Nope, nothing's moving. That's a no stuff. Nope, nothing moving there. I guess it could be an issue with this little thing down here, but I thought this was only power for like, I don't know, 3D touch or maybe the home button. That is U3801. And if we look at U3801 on the schematic, you can see that it has PP underscore VDD underscore boost coming into it. And that creates this PP2V75 underscore Mamba con. Now it does have PP1V8 touch going to it, but that is going to the enable signal. So this little chip is just using the PP1V8 touch signal simply just to turn itself on. And then it in turn, from its V out pin here, is creating PP2V75 underscore Mamba underscore con. I really don't think we need that for touch to work. All right, so again, I'm gonna go ahead and kind of just like chisel up this area a little bit, and I'm looking for loose components. So far it's looking really good. I don't have anything popping loose. No, this is all going to be fine here. There's nothing right in this vicinity causing a touch issue that I can tell. So my idea here with using the iBridge, that allows me to connect a screen assembly, but it gives me test points to be able to get to all the individual voltages that are coming from the logic board and also coming back from the screen to the logic board. Nobody's going to tell me that the screen I was testing with is actually an iPhone 8 screen. There are some weird touchy things here going on, so let's just let's eliminate that as a variable. So without a screen attached, the Chestnut IC does not put out any of the necessary voltages that we need. So if we are going to measure the voltages that are going to the touch circuit, it's necessary to have a screen attached. So I am able to check on the back side of the board. We have this 5V7 Mason line here that I can check. PP5V1 underscore touch underscore VDDH. So we can check this on the back side of the board, and also we can verify whether or not this filter is blown, but I really don't think this filter will be blown because I would have had a bad reading out of the connector, and I've been sitting here checking readings for the last 500 hours. So now I'm going to do what I should have done to start with, and I'm going to get this board powered up so I can take some measurements, no thanks to this thing. All right, so we've got the power supply turned on, and I'm going to prompt this thing to boot in 1, 2, 3. Boots. We have image on the screen. So I've got my meter set to voltage mode, and while this is booting, we are going to just go ahead and poke around here and see what we can find. Right here, I am getting a -5 volts, so that is an acceptable reading. So I'm just going to hold my probe here and wait for this thing to start up. We are at 0 volts. I have an Apple logo on the screen. Apple logo, Apple logo, Apple logo. 5V1 is present. No touch. Isn't that something? I have checked over all of the connections all the way out to the pins. Everything in diode mode tests to be fine. There's a ton of components on here that look really, really bad, but electrically they test to be fine. The whole bottom end of this board has gotten wet. The smaller connector here for our 3D touch and home button, you know, it's taken a bit more damage than the main display connector. And as we know from previous problems, there's a situation where if you have the home button connected, but the little ground pin out here on the home button connector, if these little things get recessed back up inside of here, there is a situation where with the home button connected but no ground here, you actually wind up without any working touch at all. So then just simply disconnecting the home button is enough to get touch working again. So with the bit of crud and stuff that we have going on here around this connector, I am worried about what may be going on like underneath the connector. And then the same thing for this connector here where I have just, resoldered some pins. The connector itself, I mean, it really doesn't look bad. So I don't immediately feel compelled just to replace the connector, although that may be the right thing to do. I think what I'm going to do here is I'm going to replace some of the components on the back side of the board that are just obviously bad, and then I will go ahead and run this through an ultrasonic cleaner to hopefully take care of anything that might be going on under the connectors. I'm just a bit concerned that there is something shorted or something going on under the connector that's preventing touch from working, but enabling me to get normal readings at the connector. So on the back side of the board, These capacitors over here, they certainly look suspect, right? I mean, even if they work today, there's no guarantee that they're going to work tomorrow whenever the customer gets this back. Now, I'll admit, this board is, I mean, it's in pretty bad shape, so there's going to be a lot of stuff that I'm just not going to be fixing on here. Oh, look. We'll just pretend like we didn't see that. For this, we're probably going to need some actual new components. Let's do some, let's see, 6.3 volt, 10 microfarad 0402s. I've got some 0201 FLs. These are rated at 300 milliamperinis. I have 2.2 volt, 2.2 microfarad 6.3 volt 0201s. And just in case we need to replace backlight capacitors, we've got some 25 volt 0402s. I think that's more like what this one has. And last but not least, we're going to need some big old honking filters. So let's do the 0402 FLs. So I'm going to begin warming this up with hot air. I will start with these two filters right here. You know, although they test to be electrically good, they just look really, really bad. So I'll just clean out the goop from around those. Now, while I'm in goop cleaning mode, I might as well just go ahead and continue cleaning out all this goop because I will replace a couple of these capacitors as well. Now, my hot air right now is set on 230 degrees C, and I'm at an airflow of 65. I've tried to keep it set at a place where it's not going to easily melt and float things. I'm really just trying to balance safety with speed. You can clean this glue off with some lower temps than this, but it takes forever to warm the board up, and I'm just trying to get this out of here. We're going to want to do at least this one cap here. That one looks really, really bad. So I've raised my hot air to 340 degrees C, and I've lowered the airflow to 40. Now I'm going to begin with these FLs. I will flood some flux on here. Now, instead of raising the temperature all the way up to the point of melting lead-free solder, I am going to use my iron here and begin working in some leaded. Ooh, now that we got some flux on there, we can really see those components don't just look bad, they look like really, really bad. That might actually be part of the no-touch issue here, right? Come on, don't make a huge mess. All right, so I'm going to keep warming the board up. There we go, pop one of them off there. So I'm nowhere near melting the lead-free solder with my hot air. I'm letting the iron do the rest of that work. I'm more just preheating. That one seems like welded maybe. I don't know. Yeah, there's part of it left over on the board. We got all sorts of goodness going on here. So just go ahead and fluff up these pads. So that's 1, 2. There's 2 of our nasty inductors out of the way. Now, I am going to go ahead and do, let's see here. Should we replace this one, or should I just sort of shine up the top of it and make it look like it's been replaced? I'll just go ahead and get that off the board. Oh, come on. Well, as you can see, I've dislodged another component next to it here. Everything you see here is just completely normal, folks. So we're not going to worry about any of this. We're just going to pretend like that was supposed to happen. And I'm going to remove that good filter too. Ha ha ha, look at there. A little lucky magic. So while I'm in the mood for sweeping component replacements here, and with the spirit of Paul Daniels, I'm just going to go ahead and replace that filter too. All right, let's go ahead and get these pads all fluffed up and get as much leaded solder on here as we can. Oh yeah, this just looks beautiful. I'll fluff these up. Oh yeah, looking marvelous. All right, what's this going to be? 0201? Oh yeah, 0201 FL, baby. All right, let's start putting these back on the board. Some brand spanking new components. Come on, baby. Any minute. Ooh. A little gnarly there. Okay, that one's just starting to sit into place. Let's get the other one next to it going. I probably should have spent more time switching this over to leaded solder, as it seems my melting point is a little higher than what I would care for it to be. I don't want to float everything loose on the top of the board too, you know? Oh, come on, get down there! There we go. Now I'm going to float this one next to it just a little bit and make sure it did, in fact, go into place. All right, how many more do we need here? We need 2. There we go. Isn't surface tension lovely? All I have to do is just sort of hold this thing next to where it's supposed to be, and the universe takes over and just kind of pulls it right up into place. There we go. All right, let's get this one right here in place. This is one of the backlight filters, and so is the one right next to it. Almost there. Oh, yeah. All right. Let's get our final filter in place here. Nice and pretty. Now these big old capacitors up here, they look like complete total hell. And to be completely honest, it almost looks like this one here has already started to crack. No, that may be just some glue on top. You know, this is on one of our touch power lines. I'm going to go ahead and replace all of these capacitors. I need to be really careful to not install any caps that are just radically the wrong values. You know, I don't want to install like a 6-volt cap on a backlight line or something like that. It looks like we are in luck. These are all 5V7 lines. So for this, I'm going to just be using 6.4 volt capacitors. I'm actually going to be using these capacitors, 10 microfarad, 6.3 volt, 0402. I think I've already cleaned this out pretty good. All we have left is flux. So we're going to need a big old blob of 6337 leaded solder. And we're just going to kind of start flooding this in there. We do need flux. Honestly, I should probably just go ahead and use low melt and make life really easy. See things starting to move? Oh yeah. Here we go. You can't get them all in one lift? Oh, come on. Surface tension. No! Oh no! Okay, so that's actually really sloppy. Gosh, what am I even doing here? Well, I guess I better go ahead and start cleaning this up. See if we can make a working board out of this. We were, after all, just trying to fix touch, weren't we? There we go. It's kind of like the Three Musketeers, only there's 4 of them. Well, as much as I wanted to remove them all at the same time, I'm going to settle for this. I'll settle for this as long as I don't take that row of components off the board next to it. That actually might make me quit joking for a minute. Now, before I forget about it, let me go ahead and fix this little mistake I made down here. There we go. All right, I'm just going to keep shining these pads up here and get them ready to receive some brand spanking new capacitors. And I'm also trying to get rid of as much of this lead-free solder as I can. And as I'm puffing around here with hot air, you can kind of notice where the pads will melt before the components around them. It's sort of like a built-in thermometer. I use my eyes to tell where my temperature is, you know, because just after these pads start to melt, the pads around them start to melt, and so does the lead-free garbage on the other side of the board. Now, since this is quite a lot of solder, instead of trying to just flood it with leaded and displace it, I'm going to go ahead and just kind of swap it out. So I'll use just a little bit of wick here with some hot air, and just suck it right up like that. By the way, I learned the hot air wicking trick from Paul Daniels. Thank you, Paul. A little bit more flux on there. I wonder what Louis Rossman's doing today. All right, let's just fluff these up. I never can do things gracefully when I'm recording. Just hit the rest of these here. Just bump them is usually what it takes when your temperature's right. All right, let's get us some new capacitors here. All right, here goes the first one. Now, I know these caps, they're probably tinned with lead-free, but that's going to be okay. We're picky, but we're not that picky. And by we, I mean me. I'm pretty sure I just burnt the skin off of my finger. Oh, this is just terrible. What am I even doing? Well, I guess I should go ahead and reduce airflow just a little bit. I'll go down to 35. There we go. Now, since I'm being lazy and I don't want to research what line is which here, I'm going to just kind of make sure these capacitors are not touching. It's probably okay to have them touching, but we're not going to. All right, and the final capacitor here. Set it right in there like that and just kind of keep blasting it with hot air. You mofo. Oh, this is thoroughly embarrassing. All right, here we go. Let's try to look all professional here, right here at the last minute. Don't run away again. No, 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 no. Okay. I think it's about time to throw in the towel. Let's just go ahead and separate these here once more. This is all just completely normal. So I'll just slip my blade in here and warm it up at the same time. Now you two, stay away from each other. These two caps over here are also getting a little bit too friendly, snuggling up with each other, so I'm going to peel those apart. It helps if you don't accidentally solder your blade to the board. Now we got everything separate. There we go, looks pretty much brand new. All right, what else do we have here? Should I go ahead and do something with these backlight capacitors down here? Those are backlight capacitors, right? No, actually, we have one backlight capacitor, one 5V7 capacitor, and then we have another capacitor here that has to do with Mamba. So of the three of these really nasty looking caps, I'm mostly concerned about the one on the right. That is a higher voltage capacitor, and it actually looks significantly worse. All right, so I'm going to replace this one backlight capacitor. Just start warming this up here. I'm at 340 degrees C and an airflow of 35. And just like all the rest of them, I'll use my hot air and the iron here to do most of the work. That enables me to sweep it off the board without actually warming the entire board up. There we go. Now on this cap, it's going to be really important to use the higher voltage. This is going to be the 25 volt 0402. And since I'm not trying to sit three of them all side by side and four all together and combined and twisted, I suspect this one to go much smoother. Ah, yes. A brand spanking new backlight capacitor. All right, fellas, I think it is time to... Ow! It is just about time to head off to the ultrasonic cleaner. Wonder if I did any damage on the top side. No, it looks equally bad. Before I ultrasonic clean this, I'm going to go ahead and flux and flush these connectors. For this, I'm going to warm the board up, not quite to the point of melting the lead-free solder, but just enough to get the flux to activate and boil. This is going to help with oxidization and just really help the flux do its job. I am worried that there is stuff under these connectors that I can't see, and rather than taking the time and effort to fully replace the connector, I'm going to just kind of try to wing it. Now, because we had other carnage going on up here toward the top end of the board too, I'm not just going to ultrasonic clean like the bottom of it. I'm going to go ahead and get this whole board clean, because it looks like, it looks like there was just liquid everywhere. So I'm going to do this little fluxy, bubbly treatment sort of like all over the place. You know, and try not to make anything worse, of course. Oh yeah, look. Yeah, we had liquid that got in all here around the baseband IC. So I'm just going to flood that with flux, get it to bubble a little bit, and then back out. Once again, this is 340 degrees C, airflow at 35. I'm not trying to melt solder. Same stuff down here. Baseband power management. You know, this is not a board that I would want to send out of here repaired. I mean, you can buy this phone for $100. There's no reason to send somebody out a janked up, spliced together mess whenever you can replace it for $100. Now, we can't very well pretend like this isn't here anymore because this is actually really serious at this point. Oh, come on. Don't go under that chip. Please. Ha ha ha. Got it. I'm just going to go ahead and flood Trinity. We all know that Trinity likes to have flux all over her. And all of our RF switching wizardry. Let's get some flux in there, shall we? Oh, yeah. Nothing like taking a liquid damage board and putting liquid all over it. All right, I have made this board thoroughly sticky. And now it's time to head off to the ultrasonic cleaner and see what that can do for us. All right, let's once again dip our liquid damaged board in liquid. Holy smokes, look at the flux clouding off of this thing. So next, I'm just drying all of the water and cleaning solution off with a napkin. And once that's dry, I drop it into some alcohol to get rid of as much water as I can, and then, dry it off with a napkin again. There we go. And with every fluxy step, I'm all the time cleaning up my flux, or it would be all over my arms. So now that I got this board all cleaned up, I need to dry it. I'm going to put it on a board heater for that. I want to be absolutely certain to set my temperature to something low enough so that it doesn't boil water. So I'm going to set this to, let's see. Let's do 195 degrees C. That's probably a good starting point. I got quite a few comments informing me that water boils at 100 degrees C. However, this board heater, although it may be hitting 195 degrees C somewhere down here near its sensor, or it's most likely like grossly out of calibration, it's definitely not getting 195 degrees C up here to this board, because I can literally lick my finger and touch the board heater and it doesn't go tss. So I'm going to be leaving this on the board heater for a couple of hours. Over the period of 2 hours, I'm going to gradually raise it up to maybe 200 or 205. Yeah, my biggest fear with all this is popcorning. Whenever you get water trapped under or inside chips, it can actually swell and pop inside of the chip. So just exactly how hot is this thing? So at 195 degrees C, it's got part of the board there warmed up to 150 degrees Fahrenheit. I wonder if it's showing Celsius on the screen, but it's actually in Fahrenheit, because will a calibration knob make this big of a difference? I mean, that is a radical difference. See there? My feelers actually do a pretty good job at judging where to put this temperature. If you're putting a board on a heater and you set yours to 195 degrees C, you want to be really careful if it's a wet board, because you could cause some serious damage. So my feelers are telling me this is a pretty good ways below boiling temperature, and it's been on here for a little while. So I'm going to raise this temperature up a bit. I'm going to go ahead and raise it up to 200 degrees C. So we just maybe ignore that and consider that 200 degrees F. Okay, this has been in here long enough for me to consider it dry. So here goes my very first look after ultrasonic cleaning, and I thought I was going to really regret not resoldering all of these pins, and I actually do somewhat, but it's really not that bad. These things are going to work out. They're not really good, but I don't think they're bad enough to keep touch from working or keep anything from working. Let's have a look at some other stuff. I will likely go ahead and get rid of this little capacitor down here, but not yet. I do wish I would have went ahead and just ran an iron down through here and touched all these just one time. This connector over here, I plan on leaving completely alone. This corroded filter right over here, I plan on leaving it completely alone as well. Our chestnut area looks a whole lot more acceptable. We've gotten rid of all that flux, and now I can actually see what's going on. Here's our 4 image power capacitors that I replaced. So what do you think? Think we'll have working touch? I'm actually pretty doubtful, but we'll see. I don't think any of the filters that I replaced were electrically bad. They were cosmetically bad. Let's get the power supply on the screen. I've got the power supply set to 4.1 volts. And now I'm going to prompt this board to boot in 1, 2, 3. We have an Apple logo. Any minute here, we're going to find out if this thing is going to have working touch. All right, we're up to a lock screen. Drum roll, please. Ah, yes. We have working touch. Oh, yeah, baby. That is good news. I am so glad to see that this thing has working touch. Now, I am needing to be able to send this back to the customer, able to start up to where he is able to enter his passcode and do his own data transfer. So for that, I'm going to need the components in this housing to be good enough for that. I'm also going to need the screen to be good enough for that. Now, thankfully, this screen assembly, the connectors on it actually look pretty good. I'm going to say we've got one over here that's just I'm going to say we have one over here that's just a little bit corroded. I should be able to just go ahead and leave that alone. So then that bears the question, do we have a good battery? You know what? I'm not going to spend a bunch of time testing a bunch of stuff. I'm just going to go ahead and slip this thing right on in the housing. All right, there we go. We've got its original screen assembly. I'm going to hook up the battery that's been liquid damaged. I know I'm going to get 10,000 people that say I should replace that battery, but that battery will most likely be fine. All right, let's go ahead and connect a charger. Right off the bat, we're drawing 290, 350 milliamps, and we do have a battery charging icon showing on the screen. I'd really like to see that closer to, there we go. I was going to say 500 milliamps or an amp. We are now drawing normal charging current. Woohoo! It's actually starting to look really good for sending this back able to start up. Oh, it's booting. Here we go, baby. I just felt a charge connect tone. We are up with still working touch. Since we do have charge connect, that's a real good sign that USB connect is going to work as well. Let's see, how about home button? Yeah, home button clicks. And Touch ID works. Sort of, look, it's sort of bouncy like that. You know, you could spend a lot of time trying to narrow down all the quirks and kinks that comes along with a board that's been liquid damaged like this. I mean, sure, yeah, it might be okay, but the value of this phone is literally $95. You can get on eBay and buy an iPhone 7 for $100 or less all day long. With the carnage that's going on here, it makes a whole lot more sense if this customer is after a working phone and his data, and he's just like really decided on having an iPhone 7, then it would be better just to buy an iPhone 7 and restore this data to it, and it still winds up being more stable and cheaper in the long run. So I'm going to do just a little bit more work to get this phone finished up. Now, I'm taking a gamble here. I mean, what if this guy gets his phone back and doesn't get his data? That's part of the business we're in. All right, guys, that's going to be the end of this video. I really thank you all for watching, and I will see you in the next one. Have a good day. Oof, almost forgot this little bracket. Shame on me. There we go. So the entire time I worked on this phone, there was a tag on the back of it from the previous repair shop. Although faded, it did have some information on it that included the words liquid damage and data, but also on that tag was the passcode. I was so fixated on keeping that out of view that I didn't even think to read the tag. This guy probably thought I was completely nuts for speaking like I didn't have the passcode.